Let's talk about some of the assumptions of One Way ANOVA. There are really three main assumptions. First, we assume that the data are randomly sampled from a population. So we typically apply One Way ANOVA when we're gathering a random sample from a population. If you have the full population, for example, if you conducted a census, we wouldn't conduct one-way analysis of variance. Another assumption is that the variances in the population are the same for each group. Right? This is an assumption that we require in order to conduct this kind of analysis. As a general rule of thumb, because we can't actually test this assumption about the variances in the population for each group, rule of thumb is that the largest sample standard deviation should be no more than 3 times the smallest sample standard deviation. Again, we're just using the sample data to kind of guess, really, whether or not this assumption is met. However, you never fully know. It's just an assumption of one-way analysis of variance. The third assumption is that each group is normally distributed in the population. So with one-way analysis of variance, our outcome variable is numerical or continuous. And then we have these 3 levels or 3 categories. The assumption is that for each group in the population, not in your sample, but in the population, each outcome for each group is normally distributed. It looks like a bell curve. Additionally, the one-way ANOVA is used, just to remind you, it's really only used for numerical outcomes. Now let's talk about the null and alternative hypotheses for one-way ANOVA. ANOVA, it begins by analyzing the variances or the variability, but the focus is on comparing the means. The null for one-way ANOVA is that all observations come from the same population, while the alternative is not. So we can visualize this. The null is that they're all from the same population. All these different means are equal in the population. So for those 3 mouse groups, each mean would be the same in the population. The alternative is that the population means are not equal. They differ from group to group. And you can see in the schematic here, we're assuming that that variance, that spread in the population is the same for each group. That's how one-way ANOVA works. We assume the variances are the same for each group in the population. And then we really test this claim about whether the means are all equal or not. Let's talk about the mechanics of one-way ANOVA. Again, it's used to compare the means of multiple groups. Mechanically, it starts with analyzing the variance or variability in your data. It's based on assuming all groups have the same variance. With the same variance, the possible differences are thus due to the means for each group. And then it starts by estimating this common variance. In order to really calculate one-way ANOVA, we have to talk about this concept of mean squares. So the sample variance is sometimes written as the sum of squares divided by the degrees of freedom, where the degrees of freedom is 1. And so the sum of squares is simply taking each x value for each row of our data set, subtracting out the mean. So we're kind of decentering or removing the influence of the mean. And then we're squaring it so they're positive. We're doing that for each row, for each observation. We're adding up all these values. That's sometimes called a sum of squares. So sample variance is sometimes called the sum of squares divided by the degrees of freedom. In this notation, SS is the sum of squared deviations from the mean, and DF refers to the degrees of freedom. That is the number of independent pieces of information used to calculate the sample statistic. When we use and calculate ANOVA, we're going to use a similar calculation, and this is called the mean square, which is simply the sum of squares divided by the degrees of freedom. In ANOVA, mean square, it has a more general meaning. There are many different ways of calculating some kind of sum of squares. You can compare your x values to the predicted values, or you can compare it to some group mean. The point is that this idea of sum of squares divided by the degrees of freedom, that's what we call a mean square. So the sample variance is a particular kind of mean square in which you take each observation, subtract out the mean, square it so it's positive, and add up all those values, and then divide by the degrees of freedom.